Okay. So, any doubts in the homework, anyone?
No, ma'am.
No? All right. Do you all want to discuss the homework, or should we move on with some other questions? Do you want to discuss the homework?
Yes, ma'am.
Yes? Okay, that was Munir, I guess. Okay, Munir. So let me, did you receive the questions, Munir? Did you receive the homework questions?
No, ma'am.
No. Are you sure about it? Because everyone seems to have received the questions. Okay, never mind. So the questions were pretty simple. There was one question like this. So we are discussing homework questions. This is P, this is Q, this is R, this is S and T. And okay, Avni, can you please read the what all is given in the question? Yes, Avni.
Yes, ma'am. PQ is equal to PR.
Okay, so they have given that PQ is equal to PR and
Angle Q is equal to angle R.
what do we have to prove?
Triangle PQS is congruent to triangle PRT.
Okay, so how have you done this, Avni?
First,
Hmm.
first we have to write what is given, and then angle Q is equal to angle R. Angle no
See, first you
PQ.
have to write in even in your homework, the one that you have submitted. Even in that, you haven't written this. You're always supposed to write in triangle. Like which triangles are we talking about? You have to be specific now. So in triangle PQS and triangle PRT. Okay. Then continue from here.
Angle Q is equal to angle R given.
Okay. Given. Then
PQ PQ is equal to PR given.
PQ is equal to PR given.
Angle P is common.
Angle P is equal to angle P, common angle. Munir, are you understanding all of this?
Yes, ma'am.
In this triangle and triangle PRT, this triangle. Okay. So these two angles are equal and this is common. So therefore by ASA rule, they are congruent. So done. That's all we had to do. So therefore they are congruent. Okay. Next question. Anyone else would like to do the next question?
Ma'am, me.
Yes, Preshita.
Ma'am, in this question, ma'am, actually, I don't have the question, but I have solved it and I have sent it as well.
Acha, acha. Okay, fine. Yeah, I have received it.
Okay, ma'am.
Wait,
Yeah.
let me just check your answers. You sent to me or you sent to the official number?
I'm the
Okay, fine.
official number.
I found it. Okay. Which question are you going to solve now?
Ma'am, the third one.
The third one. Okay. So what do we have in this question? We have something that goes like this. Yes. And
AB and no, AD and CB are like equal and parallel.
okay. So AD is parallel to CB and also
and
equal.
equal.
Okay, so this is AB and this is DC. And AD is also equal to CB.
Yeah.
Then what else? What do we have to show?
Um. Yeah, we have to show that O is the midpoint of AB and CD.
O is the midpoint of AB and CD. So what does this mean in mathematical terms? In equational terms, what does this mean?
That OC equals OD and OA equals
Hmm.
OB.
OC, which means this part, is equal to OD, this part. And to show that AO, which is this part, is equal to BO, which is this part. So how have you done this?
Um. Yeah. So BC equals DA. Like I just have
Yes.
to prove the triangle's congruent.
Hmm. So we are talking about which two triangles? In triangle BOC and triangle
AOD.
AOD.
Yeah.
Yes.
So BC equals DA, which is given.
BC equals, we will say AD, okay? BC
Yeah.
equals AD,
Yes.
given.
And angle BCO equals angle ADO.
Angle BCO, this one is equal to angle ADO, this one. Reason?
Adjacent angles.
They're not adjacent, bache. They're called alternate interior angles.
Yeah, I just like confused
Yeah.
both of
So
them.
remember what it's called? It's called alternate interior angles. Okay, then
And angle CBO is equal to angle DAO. Again, alternate angles.
just a minute. Let me remove this, otherwise it will cause confusion. And this angle is equal to this angle. Angle CBO is equal to angle DAO, alternate interior angles. Then
Yes.
they
So
are
therefore,
congruent by,
ASA.
okay, by ASA rule. Okay,
So
so hence by
therefore, OD
CPCT.
equals
Hmm,
OC and OB equals OA by CPCT, and therefore O is the midpoint of AB and CD.
very good. Okay. Okay, fine. So these were the two homework questions. Let's just do a few more questions in today's class, and then in the next class, inshallah, we will start a new chapter, which is Introduction to Euclid's Geometry. Okay. Okay, so let me know if we have done this question in the previous class. I'm going to draw the figure. I think we have not done this, right?
No, ma'am.
No, ma'am.
This, this doesn't look like 90 degrees because of I have not drawn it properly, but it is a square. Okay, so this is A, B, C, and D. This is a square. I'm sorry that this is doesn't look like a square. It looks like it doesn't look like anything. It just looks like a quadrilateral, but it's supposed to be a square. Okay, so
Okay,
ABCD
ma'am. Yeah.
is a square, and then M is the midpoint of AB. This point M is the midpoint of AB. Okay, I think I'll have to draw this again. We have ABCD square. M is the midpoint. Then there's a perpendicular bisector. Not bisector, sorry. There's a perpendicular. PQ perpendicular to CM. PQ perpendicular to CM. So this is C, right? This is ABCD. I'm going to
Yes.
remove this. This is ABCD, and this is PQ, which is perpendicular to, again, CM. So this is M, and this is your P, and this is Q. So PQ is perpendicular to CM. Fine. Prove that PA is equal to QB. PA means this thing, and QB means this thing over here. This is Q, this point. So you have to prove that PA is equal to QB. And the second point is CP is equal to AB plus PA. CP, which is this one, is equal to AB plus PA. Okay, so AB is this one. All right. First of all, think about how we can solve the first one. Yes.
Ma'am, they're vertically opposite to each other.
Vertically opposite angles.
Yes.
Okay, first let's write the statements, okay? What statement are we going to write? In triangle in which two triangles? See, what do we have to show? We have to show that these two pink lines are equal to each other. How can we show that?
By proving that triangles CMQ and CMP are congruent.
If you show that triangle CMP and CMQ are congruent, how does it prove these two pink lines to be equal?
Oh.
Ma'am, in triangle DMA.
DMA, where is DMA? This is P, bache, this is P.
Oh, P. PMA.
In triangle PMA
Yeah.
and
Triangle BMQ.
And triangle BMQ. Okay. Now what all do we have in these two triangles? See,
Angle
one
A
thing is
equals
given.
angle B.
Angle A equals angle B. Why?
Alternate angles.
Yes, alternate interior angles. So, okay, wait. First, let's think about what all we need. So, okay, if we take this
that's
and
what.
this, if we take this and this. Then what else?
Ma'am, we need to like find that we need to prove that AB is a straight line and PQ is a straight line.
But
Or
say you don't have to prove that AB is a straight line because
yeah,
ABCD is a square.
AM equals BM and
Yes,
PM
AM equals
equals
BM is
QM.
given, right? AM equals BM is given. Why? Because M is
Midpoint.
midpoint of AB. Okay.
Yeah.
Then what else do we have?
B is M is midpoint. Common.
M is midpoint. Done. We have used that. Then just now someone said vertically opposite angles. Now what happened to that? What happened to that
Oh
point now?
yeah.
Hmm.
So BMQ is equals to
Hmm.
AMP.
So angle BMQ is equal to angle AMP. Reason? Vertically opposite angles.
Is it?
Yes.
Yes.
Okay. So now what all have we gotten? We have gotten this side and this side. Then we have gotten these two angles, this angle and this angle. Then
And angle A equals angle B.
angle A, you mean this angle?
Yeah.
This angle equals this angle.
Yeah.
How?
Alternate angles.
Okay. They are not, see, the thing is, you just now said that we have to prove that something is a straight line. The thing is, it's nowhere given in the question that CQ is a straight line. We just know one thing. We know that, where did it go? We know that this is a square. Now, imagine there's a square like this, and there's some point over here, Q. This is a point Q. And you are just connecting this point B and the point Q. No one is saying, just because it looks like it's a straight line doesn't mean that it's a straight line because it's not given in the question. So you can't make assumptions.
Okay,
Then
ma'am.
what else?
You have shown that MP is equals to MQ, but it's AM equals BM.
I'm sorry. Yes. Wait a minute. M is the midpoint of AB, right? I shouldn't have
Yes, ma'am.
made these marks. It should be this and this. My bad. Then,
So, ma'am,
okay,
to
now,
prove that MP
huh,
and MQ are like equal, so we have to prove that these triangles CMP and CMQ are congruent.
no, you don't have to prove MP and MQ as equal. Who has said that? You have to
Ma'am,
prove
if
PA
it's
is equal to QB. Acha, you are saying that in order to prove these two triangles as congruent,
yeah,
we need first this and this as equal. For that, you are
yeah.
going to prove that this triangle is congruent to this triangle. But what do you have? You don't really have much. You just have one common side. Then you have this angle is 90. And what else do you have? You don't have anything else. Okay, let me give you a hint. Remember that this is a square. Now look at A and B and then tell me. Look at angle A and B.
Both of them are 90.
Yes, both of
So
them are 90.
so 90 degree, like angle A equals 90 degree and angle B equals 90 degree.
Yes. So angle A is equal to angle B, which is equal to 90 degrees because of the square, okay?
Yeah, so ASA.
It is actually, yes, it is ASA. So by ASA rule, they are congruent. Okay, so that means PA is equal to QB by CPCT. PA and QB are the pink lines, okay?
Yes.
Done till here?
Yes, ma'am.
Yes, ma'am.
Munir, Abdul Jabbar, you all done till here?
Yes, ma'am.
CMP, okay. So now we have to show that CP, now I'm just going to erase this. You have to show that CP, which is this one, is equal to AB, the blue line, plus PA. Think about it. How can we show this?
Ma'am, angle CMQ is 90, so the other angle will also automatically be 90.
Yes, okay, so this is
Then
90.
in the last question you told that the whole triangle AM PAM is also 90
The
because it's a
angle PAM
triangle.
is also 90. Yeah, okay.
So then isn't it 90 automatic? Like, isn't it equal?
What is equal? I didn't get it. What is equal?
Okay, ma'am, 1 minute.
Tell me, what's your doubt? Okay. See, we need to show that this pink line is equal to the sum of the two blue lines. Fine. Now look at the square. Can you see the square?
Yes.
Yes. So in this square, this the blue side, which is AB, is equal to the pink side, which is AD, and it is equal to each of these sides, right? So similarly, it is equal to the yellow side as well. So basically, AB is equal to BC, right? Because it's a square.
Yes.
AB is equal to BC because it is a square. So instead of showing that, what do we need to show? See, sometimes you need to go in reverse order. Sometimes, so you have CP is equal to AB plus PA. This is what you have to show. To show that CP is equal to AB plus PA. So now your AB can be written as BC, yes or no?
Yes.
Yes.
Yes. Because it is equal. Since AB is equal to BC, because it's the same square. Yeah. Now, instead of PA, can we write QB? Because they are equal. We have just shown. So instead of PA, can we write QB? Since
Yes,
PA
ma'am.
is equal to
Yeah.
QB. So we need to show basically what is, first tell me what is BC plus QB?
BC plus Q.
Okay, in other words,
Oh, yeah. Then
what
it's
is
CP.
what is CB plus BQ? It is
CP.
CQ, right?
Yeah. CQ.
CB CB plus BQ is CQ. So basically what you have to show, that
CP
CP
equals
is equal
CQ.
to CQ. Yes. So you have to show
So
that CP is
we
equal to
have to
CQ.
prove that CMP is
Hmm.
like triangle CMP is congruent to triangle CMQ.
Yes. So that we can do.
Yes.
Okay. So let's try to show that these two are congruent. So I am going to erase whatever I have written in the second part.
Ma'am, they can be proved congruent by SAS.
By SAS. Okay. What all do we have?
Ma'am, we have CM as common.
Okay. CM is equal to CM common.
Then we have CMQ is equals to CMP is equals to 90° H. Like, yeah, since 90° H.
CM CMP is equal to angle CMQ because it is 90 degrees each. Okay, then
And PM is equals to QM by CPCT from the
from the
first.
previous one.
Yeah.
Yes.
Yes.
So we're gonna write, okay. So PM is equal to QM
By
since
CPCT from the.
triangle PMA is
Yeah.
congruent to triangle BMQ. So
Yes.
we have to write
So by
in triangle.
SAS, both of these triangles are congruent. So therefore, CP equals CQ.
So by SAS, sorry. SAS, triangle CPM is congruent to triangle CQM. Therefore, what is equal to what? CP
Is equals to
is equal to
CQ.
CQ by CPCT. Okay, now CP is equal to CQ can be written as, now here is where you have to pay attention if any of you didn't understand the previous one, when I explained this part. CQ can be written as CB plus BQ. Understanding this, Munir, Abdul Jabbar?
Yes, ma'am.
Okay, so CB is this part and BQ is this part. Okay, so instead of CQ, we have written CB plus BQ. Now, what is CB equal to? CB is equal to AB because CB is equal to AB because sides of same square plus. Now BQ is equal to AP, or let's write PA. Okay, since by previous proof, PA is equal to BQ. So we have hence proven that CP is equal to AB plus PA. This is what we had to prove. Is there any doubt in this question? Anyone
ma'am.
has any doubt?
No, ma'am.
Anyone else? Munir, Abdul Jabbar, any doubts? Shall we move forward then?
Sure.
You all have written? Okay. Fine. Let's have one more question. So ABCD is a quadrilateral, a random quadrilateral. Okay. And no, I have not drawn it properly. Wait a minute. This is A. Then why are you joining so late?
I joined at 7:10.
Acha, you joined on time. Okay. I thought you just joined. No problem. So this is a quadrilateral. They are telling you that AB is equal to CB. So this is equal to this. Angle ABE. Now what is E? It is this. And this is F. Angle ABE is equal to angle CBF. And angle EBD is equal to angle FBD. Angle EBD is this one, and angle FBD is this one. You have to show that BE is equal to BF. That means you have to show that this is equal to this. Yes, now think about it.
Ma'am, the angles are already equal to each other.
Okay, angles are equal then. You have to show that the sides are equal.
Ma'am, BD, like, we have to show that BED and BFD are congruent.
BED, wait a minute. BED. Okay. And BFD. BFD are congruent. Acha, then how will you show that as congruent?
Also we have like BD is common.
Okay, BD is common. We have two
Yeah.
angles. And what is the third thing? We need something
Mm,
else, no?
yeah.
So we can either prove using these two triangles, or we can prove using these two triangles. This one and this one, hai na? So
Yes.
in these two triangles, what do we have? Again, we have only just one angle and one side. Anything else? Hmm.
If BC is equal to BA, then won't it automatically be equal because of the angle?
If BC is equal to BA,
Then, like, won't, it's the same angle, so the opposite one will be equal, right?
Bacha, that happens when you are talking about one triangle. Angles opposite to equal, sorry, sides opposite to equal angles are equal. That is a short form of we say in a same triangle. It's just talking about one triangle. If you have one triangle and in that you have two angles which are equal to each other, then the opposite sides will be equal. Okay,
Okay.
not two different triangles, not like that.
D is bisecting angle B, right?
D is bisecting angle B, yes. Okay. Imagine that. So we have an issue here. What issue do we have? The issue that we have is if you take these two triangles, again here you have only just one side and one angle. Yes, you don't have another side, you don't have another angle. That's one issue. Another issue, the second issue is that if you take this triangle and this triangle, then again you're facing the same problem that you have just one side which is common side and this angle. What if you could combine both of these things? What if you can take the common side of these two triangles and this side of these two triangles. So what I'm trying to say is, what if we forgot about this angle in between? Sorry, this line segment.
So
Now
then
think about it.
angle. Oh, so then by SAS, both of these triangles are congruent.
Exactly. So now which two triangles are we looking at?
BAD and BCD.
Yes. So now, see, by proving these two triangles as congruent, we are not going to get BE and BF. We are not going to get it. But by doing that, what can we get? We can get this angle as equal, right? And if we get this angle as equal, then we can use these two smaller triangles and we can show them as congruent. Are you getting me? Okay. So first in these two triangles, just a minute. In solution, in triangle BAD and triangle CBD. Yes. First of all, BD is equal to BD,
BD.
common
Yeah.
BC
side.
is equal to BA.
BC is equal to BA given.
And angle B, like angle ABD and CBD is equal.
Yeah. So just a minute. So we are going to write like this: angle ABE plus angle EBD is equal to angle CBF plus angle FBD, because ABE is equal to CBF. Or let me do one thing. I will write this in one more step. Okay, let's not skip any steps. Some of you might find it difficult. So let's write it like this: angle ABE is equal to angle CBF, angle EBD is equal to angle FBD. So when we add both of these, this is 1, this is 2, adding 1 and 2. Okay, this is how we get this particular point. So that means angle ABE plus EBD is what? ABD is equal to angle CBD. So we have this thing, then we have the BD equals BD thing, this, and this. By these three things, we have SAS rule. Therefore, by SAS rule, triangle ABD is congruent to triangle CBD. Okay, now what do we do from here? Why have we proven them as congruent? Does anyone remember?
Yes, ma'am. Because we have to prove that BE is equals to BF.
BF, sorry. But why have we taken these two as congruent? How is it going to help us prove B equals BF?
Because
by
uh,
CPCT, okay, I'm going to leave that by CPCT for now. But if you're noting this down
ma'am,
simultaneously, leave some 4-5 lines, okay?
ma'am, AE plus ED is equals to CF plus FD.
See, okay, AE, don't write this. I'm just showing you something. AE plus ED equals CF plus FD. Does this mean that FD is equal to ED? Does this mean that FD is equal to ED? No. For example, if I say 2 plus 5 equals 3 plus 4, yes, it is equal, right? 7 equals 7. But that does not
Yes.
mean that 2 has to be equal to 3 or 5 has to be equal to 4.
Yeah.
Yeah. So we cannot imply that their parts will be equal to each other. So we cannot use this. Okay.
Yeah.
We will come back to the CPCT part in a bit. Leave some 4-5 lines. Okay. So now we had to prove which two triangles. In the starting we were taking, let's take these two. Okay. This triangle and this triangle. In triangle ABE and triangle BCF. Yes. What all are equal again, Avni?
Yes, ma'am.
Yes. In these two triangles, the yellow ones, which I've colored yellow, what all is equal?
Uh, BA is equal to BC.
Okay. AB equals BC then,
B
or
is
CBC.
common.
One second. What is common?
B.
Angle B is common. Angle B is not common, bache. It is angle ABE is equal to angle CBF because it is given.
Okay.
Then we need one more thing to show that these two triangles are congruent. Either we take a side or we take an angle. Can we take this angle is equal to this angle?
Yes.
How?
Because BC is equal to BA already.
BC is equal to BA. But I am talking about these two angles, not the sides.
Because
How
by
can we?
CPCT,
Of
like we
the
have already
previous.
proved. Yeah.
Yes. So by CPCT, angle BAE is equal to angle CB, what am I saying? BAE is equal to F, no, BAE, BCF, okay? This one is equal to this one. In these two triangles, the blue triangle and the pink triangle, since they are congruent, so this angle will be equal to this angle, right? Because they are congruent.
Yes,
So
ma'am.
by
Yeah.
CPCT, these two are equal. That is why we have written like this. Any doubts? If someone didn't understand, please ask. Avni, do you want to say something? Yes, Avni. Acha, first of all, please switch on your video. I'm not able to see uh, what you're trying to say. Are you even speaking or not? I don't know because you're unmuted.
Ma'am, she had a network issue in between.
Yeah, I got that. Yeah, now Avni, can you hear me?
Yes, ma'am, I can hear you.
Yeah, so I am asking, do you have any doubts?
No doubts. Just, ma'am, I left in between. Like my audio is not working. Can you say?
So, till where did you hear properly?
Like, yeah, till A, yeah, till AB is equal to AC. Then that C by CPCT, yeah, till there.
Okay, so did you understand this thing that since these two triangles, this pink one and this blue one, since they are both congruent, this angle of this triangle will be equal to this angle of the pink triangle, yes? So since they are both equal, we have just written that over here. BAE. Now instead of writing BAD, I have written BAE because now we are going to be talking about these two smaller yellow triangles. So I hope there's no doubt why I have written BAE and not BAD because it's the same thing, right?
Mm.
Okay. So now since these two angles are equal, what can we write now?
BAE is equal BCF.
So now which two triangles will be congruent? Triangle ABE. By which rule? Yes, Preshita?
Yes, ma'am.
By which rule are they congruent now?
SAS?
No, not SAS. Look at this. This is an
Yeah.
angle.
Uh,
ASA.
ASA
No.
rule.
Yeah.
Because this is an angle. This is a side. This is another angle. ASA rule. So since they are congruent, therefore, therefore, by CPCT, what do we have? What did we want to prove in the first place?
Yeah, BE
B-
equals BF.
yes.
BE equals BF by CPCT. Any doubts in this one anywhere where you think you want me to repeat? I will repeat.
No, ma'am.
Zain, Abdul Jabbar, Abdul Rahman, Munir.
Yes, ma'am.
Yeah, what did I just ask Abdul Rahman? Okay, let's move forward. Has everyone done writing?
Yes, ma'am.
Okay. Let's do another question. Okay, this one is pretty simple as compared to the previous question. So I want you all to try it first, okay? So we have a square. See, whenever the question is giving you a square, remember that you have to use two properties of square. In somewhere in the question, you will need to use the two properties. Number one, angle is 90, and the other is all sides are equal. So somewhere or the other, you will have to use these two properties, okay, in the question. So in the given figure, O is a random point in the interior of a square such that OAB is an equilateral triangle. This is A, B, C, D. A, B, C, D is a square. This is all given stuff. OAB is an equilateral triangle. Equilateral triangle means what? All three sides are equal, right? Yes. One more thing equilateral triangle means. All three sides are equal and
All three angles are equal.
all three angles are equal. Very good. So then after that, we have to show that triangle OCD is an isosceles triangle. OCD means this one.
Yeah.
Okay. So first of all, okay, fine. First of all, I'm going to let you guys think about this. It's pretty easy. You can do
We
it, I
have to
know.
prove that BOC is congruent to AOD.
Very good. And how will you do that?
Ma'am, I might require a few, like a minute or two.
Yeah. Take a few minutes. Remember the two things I told you about a square, the angle and the side. And then over here you have one more thing, equilateral triangle.
Ma'am,
Both of
today we
them
have
are
extra
congruent
class.
by
Okay, just a minute. Avni, yes?
Ma'am, do we have extra class today?
No, you don't have an extra class today.
so ma'am, both of them are congruent by SAS.
I couldn't hear what you said previously. Yes, Preshita.
Ma'am, both of them are congruent by SAS.
What all sides, what all? Okay,
Ma'am,
first of all, you're talking about these two triangles, right? This one
yeah, BOC and
and
AOD.
this one. Now what is equal to what?
Ma'am, OA is equals to OB since AOB is an equilateral triangle.
Okay, just a minute. So since it's an equilateral triangle, OA is equal to OB, then
And OC is equals to OD since it's an isosceles triangle.
bache, one sec. OC is equal to OD. Since it's an isosceles triangle, you have to show that it's an isosceles triangle.
Oh, yeah.
Okay, I'm going to give you a hint. All the sides that are equal that you're going to need in this question, I am going to mark them as the same color. Now think about it.
Yes, ma'am. Um,
OA equals OB, you have already said. Then what else?
yeah. AD equals to BC because it's a square.
Yeah, it's a sides of the same square. One more thing you need.
Yeah, one of the angles or two of
See,
these.
side you obviously don't have the two sides as equal. It's not given
Yeah.
that they are both equal. Why? Because that's something you have to prove. है ना? In order to
Yeah.
show that OCD is an isosceles triangle, you have to show that
So,
OD
ma'am,
equals OC. So one
yeah,
more
the
thing you need.
angle.
The angle. Which angle do you need?
OBC and OAD.
If you have this, this won't give you an SAS. Na? See, when you have two angles, it doesn't matter which order they are in, AAS or ASA, it will work. But if you have just one angle and two sides, then the angle has to be between these two sides.
Yeah.
So is the angle between these two sides? It's not. We
No,
need
ma'am.
this angle and this angle.
Yes, ma'am.
It's pretty simple, but I guess maybe it's a little late for you guys. That's why your brain juices aren't working. Come on, it's a square. Look at the angles of the square. And then there's an equilateral
Oh, yeah,
triangle
ma'am.
inside of it.
It's both of them are 30 degrees
Yeah.
and
So
equal, both the
see,
angles.
this is going to be 90 and this is going to be 90.
And it's
Now,
an equilateral triangle, so
yes.
60
So
and
this is
60.
30, this is 30. So what else is left? This is
No,
left
ma'am, it's
60, this is
60.
60. Yeah,
The inside is 60.
yeah.
Yeah,
So
so
let's write it.
angle OAD is equals to OBC. And since this calculations.
Yeah, since this calculation. So let's write that calculation. Okay. Since angle DAB is equal to angle CBA is equal to 90 degrees and angle OAB is equal to angle OBA is equal to 60 degrees. Reason being equilateral triangle. Sorry. Yes, 60 degrees. 60 degrees. So therefore, this minus this, the first equation minus the second equation, DAB minus OAB is equal to angle CBA minus angle OBA is equal to 30 degrees, which is DAB minus OAB, DAB. Abdul Rahman, Abdul Jabbar, Zen. Okay, Zen is also not here. Okay. Fine. Avni,
Ma'am,
DAB minus OAB gives you what? Which angle does
DAB minus.
again, once again. DAB, which is this angle, minus
Hmm.
OAB, which is this angle, gives you which angle?
DAO.
Very good. So it gives you angle DAO. And similarly on the other side, it gives you angle CBO. So these are the two angles that we need over here, okay? You can write it the other way around as well. It's the same thing. So therefore, by which rule? By SAS, they are congruent.
Yeah. And so by CPCT, OC equals OD.
Very good. So by CPCT, OD equals OC, and that proves what?
OD equals OC.
Yeah,
Yes.
that proves that triangle OCD is an
Isosceles triangle.
isosceles triangle.
Yeah.
Okay, please write till here. Okay, let's do just one last question. One last question, okay? I'm going to write the question down. Please copy it. The line segments joining the midpoints M and N of parallel sides AB and DC respectively of a trapezium ABCD is perpendicular to both the sides AB and DC. Prove that AD equals BC. So let's draw the figure. Are you all done writing the question?
Yes, ma'am.
Yes, ma'am.
Okay. So let's draw the figure. So there is a trapezium. The line segment joining the, okay, so this is A, B, C, D. AB and DC are parallel given. The line segments joining the midpoints of these two parallel sides. So midpoint of AB is M and midpoint of DC is N. And this line segment that is joining them is perpendicular to both the sides. So this is 90 and this is 90. And these two sides are obviously parallel because it's a, the side AB is parallel to, let's write it over here, given AB is parallel to DC, that's given. And then MN is perpendicular to AB, MN is perpendicular to DC. You have to show that AD is equal to BC. That means this side is equal to this side. How will we show that? Oh no, sorry about that.
It's already given.
AD is equal to BC is given.
No. Since it's a ma'am, it's a trapezium, right? So
Yes.
the sides are parallel, so won't it be equal?
No. In a trapezium, opposite sides do not have to be equal. A trapezium is a figure, just remember the definition of a trapezium. A trapezium is a figure in which only one pair of opposite sides is parallel. There is no such thing in a trapezium about being equal. That is no condition.
Okay.
So it's not given to us that these two are equal. We have to prove that these two are
So
equal.
it's given that both the triangles are 90.
Which two triangles? Acha,
Uh,
angles, yes. It's given that
yeah,
these two
angles.
angles are 90,
Yeah.
yes. Okay, let me give you a hint.
Ma'am, just a second.
Yes, now think about.
So, ma'am, we can just prove that triangles ADN and BCN are congruent.
ADN and BCN are congruent. How will you prove that?
Okay, that's what I did not think about.
It's okay. Think.
Can you give a
Ma'am,
clue?
we just have like we have
Okay, before proving this as congruent, can we prove? Okay, to prove this as congruent, we might need this side, right?
yeah.
So can we take? We know that AM equals MB, right? Because it's a midpoint. Acha, one more thing. I'm sorry, I forgot to mention that M is midpoint of AB
AB and N is the
and N
midpoint
is
of
midpoint
DC.
of DC. Now can we prove these two triangles as congruent? Let's try to prove
Yes.
these two triangles first.
Yeah, so we have AM equals BM. Then
Just a
both of
second.
the
Triangle
yeah.
AMN and triangle BMN. Yes. Now continue.
We have AM equals BM.
Yes.
Then we have angle NMA is equals to angle NMB, 90 degrees each.
Angle
NMA
NMA is equal to angle NMB
NMB, 90
is equal to
degrees
90
each.
and MN equals MN common.
Yeah,
So by which rule?
SAS.
SAS. So by SAS rule, they are congruent. So therefore, AMN is congruent to triangle BMN by SAS. That means what is equal to what now?
So that means BN is like by CPCT, BN is equals to AN.
AN is equal to BN. Acha, we will need one more thing, which I will tell you about later. So now let's look at these two triangles.
Yes, ma'am, we need the angle.
Which angle?
BNC and AND.
We will need that angle, right? So, but that angle, it doesn't come in these two triangles. So can we take this angle is equal to this angle by CPCT?
Yes.
By CPCT of these two triangles, which we have just proven as congruent. So angle ANM is equal to angle BNM by CPCT. Okay. Done. Now let's look at these two triangles. In triangle ADN and triangle BCN. Yes, get started. So before we go to that, just a minute. I want to write this here itself. That triangle ANM equals triangle BNM means that 90 degrees minus angle ANM is equal to 90 degrees minus angle BNM. And 90 minus ANM is how much?
B and C. Oh, no, A and D.
Yes, 90 minus this angle, because see, this angle is 90. So
Yeah.
this 90 minus this angle will give you this remaining angle, which is
Yes.
angle AND. So angle AND is equal to angle BNC. Okay. Now look at these two triangles. What all is equal? ND is equal to NC because it's a midpoint.
Yeah.
AN is equal to BN. We have just proved.
Then
Angle AND is equal to angle
B and
BNC.
C.
We have proved.
Yeah.
So
So therefore, SAS.
by SAS they are congruent, and so AD is equal to BC. Done? Any doubts till here, anyone?
No, ma'am.
If any of you is having any doubts, you can always contact me on my personal number, and I guess all of you have my number. So you can contact me, you can ask
Yes,
me your
ma'am.
doubts, okay?
Yeah.
The next thing we will do is we will have a test on this chapter.
Okay, ma'am.